Okay, so in our previous video, we actually mentioned about your resultant forces being balanced when there's no resultant force. And if you have a resultant force, this is what we call by unbalanced forces itself. So first thing, your Newton's first law itself actually corresponds to when forces are balanced. And what that we know about forces are balanced itself, when we say forces are balanced, there is no resultant force. Okay, so when there is no resultant force, we only have two different scenarios. We will have either you remain at rest or you'll move at uniform motion itself, where this is actually referring to constant velocity. Okay, so we have these two scenarios. So what it means is, if my object is already stationary, it will not move unless there's an extra force, which is your resultant force. Since we have no resultant force, we have no extra forces, basically my stationary object will remain stationary over here. Okay, stationary object, no resultant force, remain stationary. Okay, now similarly, if you were already moving and they tell you that resultant force is 0, or they never actually tell you it, okay, keywords are constant velocity. So because there is no resultant force, you will move at these two. So basically what this says is, if you were already stationary, you'll remain stationary. If you are moving at the start and now there's no more resultant force, you don't stop, you actually continue moving, but now you're moving at constant velocity now. So you are not stopping, you are not slowing down, you're not speeding up, because if you recall, what are the effects of a force? A force can change the speed of object, right? So what does that mean? If I do no force, means no change to speed. Okay, so I do not slow down and stop. I do not speed up and move faster. So because of this is actually linked to that. Okay, so now if you notice below this one, can you add in the word R here? Okay, it should be resultant force equals 0. Okay, scratch this out. Okay, cancel this out. And write resultant force is 0. So if the resultant force is 0, take note. First thing, your object, your ball, is sitting on your surface. So typically when we draw, first thing, we'll draw your weight, W, and we'll draw your normal force, N. Okay? So you have one upward force, you have one downward force. How do we find your resultant force? We will just take resultant force, will be W minus N. This will give us a value, and don't forget, they tell you that this is stationary. The two forces, now is my ball moving? No, right? My ball is actually not moving. So what does that tell me? My resultant force is 0. So if my resultant force is 0, what does that tell us? N and W are exactly the same. And take a look, what is W? W is actually your weight. What's the weight formula? W equals to M times G. Okay, so W equals to M times G over here. What's your M? Your M is 450 grams. Take note, this is not SI units. So your M, first thing we need to divide by 1000 to change it to kg first. So for those who have trouble, mass M is your 450 grams, right? So if you want to change it to a kg, what do we need to do first? First, if you notice, we do have the prefix, right? So we will divide because we don't have the prefix. So you end up with 0.450 kg, which is what we have down there, 0.45 kg. Okay, so because of this, after you press the calculator in, if I'm not wrong, you should get 4.50 newtons. Okay, or more specifically 4.5 for 2SF. Okay, so you have 4.5 newtons over here. So this is how you can solve your upward and normal force. Now take note, this diagram is actually wrong. Why? Because your normal force should be at the surface, not at the top of the ball. Okay, so that's one of the wrong things. So you need to take note, you should be drawing like this, not like this. Okay, so if you want to present your answers, you can write resultant force, W minus N is 0. Okay, don't need to write it out in words. You can use symbols to represent it. So similarly, if you see this man over here, he's pushing the box at constant speed. When you have all of these keywords over here, like just now your stationary on top, right? What I recommend that all of you do is you write this resultant force 0n. Okay, because if you write there is no resultant force, it's very, very long. So just write RF is 0. This is just to show yourself and remind yourself that your forces must be 0. Okay, so resultant force is 0, as you can see down here, as I written down here. So because you move at constant speed. So what does that tell you? Your rightward force, your leftward force, up and down, they are gonna be exactly the same. Okay? When you have any kind of resultant force 0, what does it tell you? Up equals to down, left equals to right. Okay? So if you write the formula out, resultant force is you push the right forward, right, minus your left, right minus left. Okay? So your resultant force is always going to be this format. Okay? F2 minus F1 itself, and then we have to tell you that this is 0 because you are constant speed. So what does that tell me? My small f, which is friction, is going to be the same as my big F. And big F, they tell you is 20 newtons. So you can see your frictional force, small f, is 20 newtons. So if you need to write it, it is big F minus small f equals 0. Can you all see that? Okay, so you can see every time we are solving any kind of question itself, what's the very first step? The very number one first step is to draw your free body diagram. Draw your free body diagram. Then we will use this formula to solve. So you notice every single step that you do is always to just draw free body diagram first. And the second step is to write resultant force formula, and then you solve for your unknown values. So before you form your equation, you need to identify the keywords inside your questions, like constant speed, stationary. All of these are your keywords that tell you what is going on. Okay, so take note, the next part over here, this one, uncommonly tested, but when it comes out, a lot of students will get stunned. So just take note. Now we have a new term called your inertia. Inertia is the tendency to resist change to its motion. And this is affected by mass. So how is it affected? The larger the mass, the more inertia you have. Okay, so what exactly is inertia? So if you try to take a bus or MRT itself, when the MRT or bus starts to move first, what happens? We will move backwards, right? Why is that so? Because our bodies will want to remain at rest, but the MRT moves. So what happens is, okay, this is when it stops, when the MRT stops, we are standing on the bus. Okay, so what happens is when it starts moving, what happens is the bus moves, but our body wanted to stay where it was. Okay, so this, how to say, this is your original position. So let me use a different card, the dotted line, to show you where we stood. Okay, this was where we stood, original. But because my bus moved, the whole bus moved, right? So because of that, you actually, your head will still remain at this original position while the rest of your body actually move. So that's why we actually jump backwards when your bus starts moving itself. So similarly, if you suddenly stop, then you will actually jerk forward because of that. This is due to your inertia. Inertia linked to your mass. Very, very important. You'll need to link the relationship. Okay? So let's take a look at this. Now, this diagram itself, can you cancel this? It's a bit wrong. So just imagine the man is just holding the box at the bottom. Okay? Because if you place another hand on top, there's going to be another normal contact force. So because of that, let's not do that. Okay? So this is the man. This is the ball. Okay, so let's draw a free body diagram of the ball itself. First thing, we always gonna start with your weight W. And because the man is holding it up, now he's not applying a force, but the force, because he's touching the ball, there will be a normal force. And is this ball moving? This ball is not moving, right? So what can we actually say? Okay, maybe I'll use like teacher's favorite cloud. Okay, my teacher like to use a cloud, so I'll do the same. Do the cloud, do the cloud. So what can we say? Your resultant force, because you're not moving, now typically it will take down minus up equals to 0 because we are not moving. So what does that tell us? N and W are the same value. Okay, so if they are the same value, you should have roughly the same length. Okay, you should have the same length, because some schools, if your lengths are different, they'll actually penalize marks from you. So you need to be very, very careful about this. They must be the same length. Okay, so if you're worried, feel free to just grab a ruler and draw them. Right, so determine the force applied by Brian to hold the ball. This force that you see down here, this is actually your normal force. Okay, so what is this force? So you can actually, I have literally written out the steps for you. W minus N is 0. N is the same as W. And what's W? W is your weight. What's the formula for weight? W equals to mg. So let's go back to the top. M tells us its mass is 100. Now this is 100 grams. So to change it to kg, this is what we do. Now if the question doesn't tell us what's the value of G, we can assume that it is 10 newtons per kg. So because this ball will be 1.0 newtons. Okay, so your force applied will be 1.0 newtons. Now next, when the bus driver steps on the brake to stop his car, so he stepped to stop his car, right? So at the start, you are moving. And at the end, you stop. Okay? So what happens is this is going to tell us using the back will slide forward. Now, why does the back slide forward? Is due to your inertia. Because your inertia wants to keep your back moving. So if the rest of the car stops, but because of inertia, you will continue to keep moving. So why does the back slide forward? Due to the inertia of the back, it will remain moving forward remain in its original state of motion, which is moving forward while the rest of the car stops. Okay, so because of this, the rest of the car stops, but your back is still moving forward. So this is actually due to your inertia itself. Okay, you can see the keyword here is your inertia, and it is going to remain moving forward. Okay, so you remain moving forward. All right. So this part itself is just to keep emphasizing the keywords, which is actually inertia is the tendency to remain in your original state of motion. In this case, you want to be more specific to this question itself. You will want to remain moving forward. So when you move forward, the rest of the car stops. That's why your back will actually fall forward. That's why most of the time we tend to wear your seat belts, because if you suddenly brake, what happens is that your head will actually jerk forward. You might actually hit the front of the seat itself. So you need to be very careful. Please wear your seat belts carefully whenever you're in a fast-moving vehicle.